All right, let's. I think we had promised at one point that we would put a finer point on the limit definition of the integral. So today's that day, okay? And by the way, today and tomorrow, we'll do as much as we can on this. We'll talk for 10 or 15 minutes about this, and then we'll continue tomorrow as well. So I don't plan to finish this today. We'll do it in 2 parts. All right, and by the way, this content today and tomorrow is the last stuff that is covered on Thursday's quiz. So this limit definition of the integral stuff. All right, the packet in front of you is your notes for this. Okay, you see this text appearing? Thanks, guys. Appearing exactly in front of you. Yes, in class it says in class. Okay. So if someone would read that for me, how about go ahead, Cameron. Yeah, it's in front of you too if you want more.
Class, we said that the depth integral is defined as the limit of the sum of variables. This made sense because even though other shapes often provide good estimates, rectangles are easy to implement systematically. As we increase the number of rectangles, or equivalently decrease the size of each subinterval, we obtain the exact value for the desired integral. We use the following notation. The notation.
Keep going. You want to keep reading? You're doing a great job.
The variable n relate to the index of the sum k, or to the size of each subinterval, delta x? And how do these relate to the limits of integration a and b? In the following activity, you will explore this idea in more depth and obtain exact expressions for integrals using precise notation.
Thanks for the gesture too. It was very well read.
My monologue performance for English.
Yeah, that was good. That was really good. The overarching idea, though, is this is the notation we listed before, right? I think this is directly taken copy-paste from your notes previously, which made sense from an intuitive standpoint. But when you tried to actually formalize this, and you're like, wait, hold up, what's k? Where are the a and b? Right? You kind of you were like, wait, this doesn't seem immediately obvious how this can be algebraically applicable to our situation. So let's actually go through an example of how we can use this definition, try to tighten it up a little bit. And our first example, I'm not sure it's the world's best example, it's just the one that I put in here, is 5 to the x. I just wanted to pick something that you don't know the area under by almost any other means. You'd have to approximate it, maybe using tools we have right now. This geometry won't help. So there's the picture. And of course the area I've shaded, which is not so clear on yours maybe, but is from -2 to 0, which is the integral I'd like to calculate. So go through with the people nearby and calculate for number 1 and 2. And again, we're focusing on the form of the computation. Think about the kind of thinking that we saw in the warm-up today. I don't even really care about that much about the answer here. It says write out the calculation, but don't compute it. I really want to know. We want to study the structure of the expression that you're coming up with. Okay. So, and then when you're ready, do number 2. Number 1 and 2 are kind of like the warm-up again. What? Yeah, you don't really need a calculator per se. You just write out the rule here. This doesn't have to be done in isolation. If you want to ask the person next to you what they're doing, what they're getting, how they're approaching it, that would be fine. kind of sequence is that in number 2? Remember the name of that
I think I
sequence?
did it.
Yeah, the geometric sequence, or excuse me, arithmetic sequence.
Understand it better.
What's going on, everybody? How you guys doing?
Yeah, sure.
Why?
So when would you write out your answer when you're done?
We already know what the guess is saying.
Well, we should do that. Showing it as a
Do you guys agree up here? Let's see, let's get, what's the rule for the sequence here? Just the sequence. Go back to pre-calc here. What's the rule? Let's say AK, we'll call it. What's the rule for the kth term of this arithmetic sequence?
A minus 1 plus 0.5.
Well, I don't want it to be recursive, though. I'd like it to be an explicit rule for the kth term. Does anyone have that? What is it? Yeah, or it depends on whether you're starting with k equals 0 or k equals 1 is just what. So depending on whether you're starting with which index you're starting with. If you're starting with 0, this. If you're starting with 1, this, right? Okay, that is not the answer to number 2, but that is the answer to the first part of number 2. Okay? So depending on whether you start with k equals 0 or with 1, you might have an index shift, right? So think about the kinds of thinking we were doing over here. It depends on what we were talking about. When you go to write summation notation, you'll be making a choice, just like Ben and I made different choices in the warm-up. We're doing. So we're just re-expressing again the answer from number 1. That's all we're doing. I want it to be exactly the same thing as number 1. Just written in summation notation. That's all. You can use 5 to we know that. We have that, by the way. Keep going now on to number 3 and 4. This is still the same example. I'd like to abstract this even more now. So Rosie is doing it differently perhaps than you might have, but maybe probably half of you did what she did. I don't know. Do you like what she has though? Do you agree that as you plug in 0, 1, 2, and 3, you do in fact get exactly the same expression as what appears here?
Wait, that's not what I did.
Something seems to... Oh, and actually, by the way, let's see. Wait, this does look a little different. 0, if you plug in, you get negative 1.5 as the exponent. So maybe you start here, And go backwards. I need to think about why. Who wrote this for me? Showing you. This is okay, but you wrote it kind of like backwards as other people might have written it, right? It's still right. It's just a lot of you probably wrote this. Right, people out there? Can you confirm? A lot of you wrote it this way. Sorry, 1. Right, it's the same thing. It's just in reverse. How did we do? Sorry. All right, so this does come out to that. Does anyone have a question 1 or 2 before we start like launching into abstractions in number 3 and 4 here? Even more? Yeah, go on.
Should we leave it like that, or should we leave it like just to the...
I think since we have the function, you're welcome to put it like this, how about? We didn't have a function normal, so we had to do that. Yeah.
If you did 1 and then 4, would you then do k minus 1?
1 and 4, k minus 1. Yeah, then you'd use the second version. Johnny? So 0 to 3, anytime you calculate the number of terms in a, so if this were correct, which it isn't, it's okay. How many terms is this? 7 minus 2 is 5 terms? No, actually.
Well, why did you give me that equation? I could have figured it out by myself.
How many is it? Go ahead.
I respect your authority.
Go ahead. How many is that?
I thought it would have been 7 things, because there's 7 on the top.
Well, no, I mean, we start at 2, though. So just plug in 2, plug in 3, plug in 4, that's 3 things. So 5, 6, 7. So it's 6 things, actually. Wait, does that always happen? How many things is this? It's 49, right?
No, it's 50.
Oh, it's 50 because you're also plugging 0 in, right?
Oh, okay.
So what's the general rule? Someone remind us from pre-calc or something. Well, okay, it's this thing minus that thing plus 1. Remember, that's like a fundamental rule when your teacher assigns you, like, I'd like you to read page 2 through 7 tonight. They've assigned 6 pages of homework, right, of reading. Haven't they? Okay, I just want to make sure you're clear on that.
Was that your invitation of the teacher?
Yeah. I have to sound like more astute than I am, more literary. All right, so let's 0 to 3 make sense. Yeah.
Or like the K or the N or whatever. Are you looking at a negative number?
K we usually let run through, like either from 1 to the number of rectangles you want, or from 0 to 1 minus the number of rectangles minus 1 that you want or something. But no, K is usually not treated as being negative. Theoretically it could be, but you'd have to like go out of your way to do that, and it would be annoying.
My way was simpler than
We definitely don't want non-integer K's. We definitely don't want non-integer K's, that's for sure. Okay, so, all right, so then it asks you to repeat the process from 1 and 2, and do that again with 8 intervals. This time, again, though, with you don't have to write it out necessarily. Summation notation gives us a very quick way to write it, doesn't it? Do the same thing with n intervals. Now we've gotten very abstract. Okay? We'll have to continue. We still have a couple minutes, but I just don't think we'll have to finish all this discussion for the next two. The homework tonight, though, is to finish the RAM festival, the one you started after the. So finish that, and then we'll just return to this discussion tomorrow. It's no big deal. No big deal. Huh? Huh? Say it again. What did he say? Mel? Oh, the RAM. No, that was Elvis, right?
Addiction, Jasper.
I came up with 2 possible
So
answers.
you're gonna like this because we were talking about hours.
I just have you. If I do, I want to 8 and I'll go.
adding up. But are they these things? I'm not fully level.
Any junior walking their heart's broken right now. Or only get to what is your
I don't know if I passed.